group the impulse. We have started this group to help the candidates who are preparing for GAT. For this, for the very first query which we have got on 24th, in this the question says that if Vs is varied from 0 to 100 volt, then out of which Zener diode will break down, and the corresponding characteristic for this diode, this Zener diode D1 and D2 are given. So what will be our thinking, what will be our procedure to solve this? First of all, if we see, if we increase this voltage, then definitely this is the leakage current, and after this voltage, this minus 70 volt for this D2, this is the Zener diode breakdown voltage of this diode, and this minus 80 volt is the Zener breakdown voltage for this particular Zener diode 1. So what happens when we increase this voltage? Definitely the leakage current through these D1 D2 will increase, but at the same time we know that this D1 and D2 are connected in series. Definitely whatever the current which will flow from this diode D1 and whatever the current from this diode D2 will be equal. So I can write here the current which is flowing in circuit is I. So this current I will be equal to ID1 equals to ID2. Let us suppose at a particular voltage, I am not naming it what is the exact value of the voltage. My operating point is this. Definitely the current ID1, ID2 and ID1 both are equal, but the voltage distribution across this diode and this diode are different. The voltage VD1 corresponding to this is this, and from this diode D2, from this characteristics we can see the voltage across this Zener diode is VD2. We can conclude here that both these diode connected in series, but the voltage across this is more than the voltage across this diode D2. So in every case VD1 will be greater than VD2. It is not the case if we connect here a resistance, suppose R1, and this is R2, and I am connecting here with a voltage Vs. So the distribution of voltage across this D1 is more. So we can basically think in that way that D1 resistance is more than R2. It's really analogous to this, but it is not the case. We are connecting not connecting resistors here. We have connected Zener diode here. So under this condition, we know that none of the diode is conducting. Let us take another operating point. Now at this point we can see here that the reverse voltage across this diode D1 is minus 80 volt, and somewhat here from the characteristics we can say that it will be VD2. So if the voltage across this Zener diode D1 is minus 80 volt, VD1 equals to minus 80 volt, definitely the voltage across this VD2 will be minus 20 volt, because the voltage, maximum voltage can be up to 100. So minus 20 volt. So from here we can conclude that Zener diode D1 conduct because of its avalanche breakdown. At the same time VD2 does not conduct. Now let us move to a different region where this Zener diode D2 will in its breakdown region. So under that condition, the voltage which is offered when this D2 will be in reverse bias, in its breakdown region will be minus 70 volt. At the same time we need minus 80 volt for this breakdown of this diode D1. So overall, if we want that this D1 diode should break down and D2 should break down, so for this we need minus 150 volt. For VD1 we need minus 80 volt, or for VD2 we need minus 70 volt. If we apply maximum, if we apply 150 volt or more than this, then there is a possibility that both diode VD1 and VD2 can be in average breakdown region. But here we have applied 100 volt, so only the possibility is only this D1 diode will break down and D2 will not. Thank you.